we are able to welcome Bjorn to participate and take the stage. Now I think it's time for evening beer for you, and we are just drinking our morning coffees, but okay, that's good. So now I don't spoil anything more of your presentation at this point, so feel free, Bjorn, stage is yours.
Thanks, thank you, Aki, and thanks, Lai, for the great presentation. I'm sorry I won't be able to reference to anything you said because my Finnish is rather bad. So apologies if I say things twice that you already presented, but I hope you'll find joy in this. My name is Bjorn, obviously. I'm a structural engineer living in New Zealand since 11 years. I graduated in Germany, in Bavaria, a while ago, and specialized in timber engineering back then. And at the moment, I'm working for ENGCO Consulting Engineers. I'm the technical director there for Timber, and I'm seconded to Timber Unlimited, who I'll be representing today. Timber Unlimited is an entity that is funded by the government here in New Zealand and is trying to make timber more accessible for the industry, designers, developers, and everyone wanting to get in touch with the material. So let's see if this. So New Zealand is often disappearing from all the maps in the world, often forgotten. But believe me, we're here. It's the other end of the world. It's dark and it's night. And to give you a rough idea, you guys are in Finland, which is approximately 1.3 times bigger than New Zealand. And since New Zealand is right in the middle of the ocean, we've got quite extreme weathers. We've got the mountain range in the western area. We've got the flat part of the country on the east, on the South Island, and the north is kind of hilly with a couple of ranges and the odd mountain range, and then very, very flat and subtropical in the north. So the rainfall obviously is very high. Why am I telling you that? Just hang in there. We'll come to the point. Now it's really hot in the north and medium to cold in the south. And the whole country is divided into various of climate zones. And if you are precise, it's 12 sub-climate zones in total. So both of the islands together have quite a bit of different climate to share. Now, this obviously results in the equilibrium moisture content in any timber, whether it's COT, glulam, LVL, stick framing, or even the timber that you have in your house as a floor. So the standard here in New Zealand does suggest a certain equilibrium moisture content for different areas. And as you can see, they are quite different. So we're sitting all around between 12 and 20%. Now, 12 and 20% would be a number that you would think in Europe we probably specify more close to 11 plus minus 2. Now, this is currently being reviewed whether it's applicable for mass timber and we can use it. But at the moment, this is a guidance of where we should expect the timber to be when it's in construction. So why all this? Well, the current construction practice in New Zealand is not necessarily that advanced in mass timber. Mass timber has just started to pick up 5 years ago, pretty much. And at the moment, we're still dealing with stick frame construction, very narrow framing. A lot of the time we have ponding water, so puddles all over the site, and we have long open times. Sometimes these buildings stand 6 months in the rain. 6 month rain and timber doesn't work very well, but New Zealand is treating the timber, so we put a lot of chemicals in, which is unfortunate and definitely not the nicest thing to do, but it's one way to obviously get around the problems that occur. And then we look at timber, especially mass timber, as if it was concrete and steel. So we're dealing with it in the same way, which is, as you probably know, not the right thing to do. And what happens? Well, you can see here, you get all the construction sites with ponding water, exposed to rain. It's not bad everywhere. So I'm just showing you the negative examples here just to make you aware of where we're at. There's definitely really good contractors and engineers and companies that are doing a great thing. But it would be boring to show you great CLT buildings because you have them over there as well. So one of my favorite photos is this. In this case, the builder actually rang and said, what do I do about the jib that we want to put on the walls? And the last worry was the jib, because this side has been exposed to wind, weather, and rain for several months. So the broken, or the jib that he had to get rid of, was the last of his worries. And if you see the floor around it was already started getting moldy and had black traces from weathering. So what we are doing as structural engineers in New Zealand at the moment, to get better, we start to specify measures that can help to obviously keep the timber away, keep the moisture away from the timber. And the currently best methodology here in New Zealand for the dollar value and most efficient one is to apply membranes. They come in different colors from different manufacturers and suppliers. You will know pretty much all of them. I won't name them today, just for the sake of it. And what we want with from these membranes is we want them watertight from the outside, so they protect, and we want them transparent, like we want them to be open so the water can evaporate that is trapped in the mass timber. So ideally an SD of 0.3 meters, which is very low. And other things we tend to use in New Zealand currently for glulam beams in particular is coatings and sealer. Unfortunately, we also use CCA, copper, chrome, arsenic, and boron to treat the timber to be resistant against decay. As you can see, that's chemicals, and those chemicals won't be really something that you would want to have in your house. However, that is currently the only, not the only way, the way the construction industry is running. However, we're moving slowly into the direction where people are aware of too many chemicals in the material, finding ways to basically analyze the expected moisture content, and through alternative verification methods and solutions, we get to a point where we're able to use untreated timber in certain applications, which is ultimately the go. The coatings, unfortunately, don't seem to work too well on CLT. That's something that needs to be researched a little bit more. CLT, as you know, has the lamellas, and if the lamellas are manufactured slightly on the more moist side and then drying down during construction, the gaps are opening, and most of the sealant is not it's not gap bridging, and therefore the gaps will open and moisture can get into the lamella on site. That's what we obviously want to avoid. So the other things you can do, everyone does it. We use the New Zealand original squeegee, a wiper. You need a lot of people and manpower in New Zealand. If you imagine that you have a lot of rain, some days you have too much for this to happen. So if that's the case, we obviously start with draining the water away from the floors. For that, some of the contractors utilize the lifting holes and added pipes to it, so the water is driven away from the building. So how do we specify moisture measuring, which is obviously a big part of the management on site, which is really important. As a structural engineer, we do provide our requirements, our thresholds, which you can see are quite low here. So this is something that's been specified a year and a half ago. In the meantime, we have realized those values might not be applicable for all sites in New Zealand and achievable. So currently we're writing a moisture management guide here for the country that's more suitable for the actual expected equilibrium moisture content for the particular zone in constructions. At the end in service, we do have, or we desire similar moisture content as you do in Europe as well. For durability in New Zealand, why I'm telling you that is because we have a slightly different approach to the Europeans. We've got a certain lifespan. That's what the Europeans have as well. Then we've got a certain exposure. That's what the Europeans have as well. But then our moisture content that we specify to be acceptable, that's slightly on the different side. So for most indoors, we have 18%, and for anything that is exposed to the external atmosphere, we specify 20%. Now, 20% does probably ring the alarm bells with a few of you. At 19% is when you start to grow mold. So what do you need to do? Well, you need to put chemicals in to make this durable. However, chemicals don't help against the mold. So what you end up with potentially unhealthy buildings, which at the moment, the only way around this is the Wiiste analysis, which currently still in New Zealand is an alternative solution that I mentioned before, but it's increasingly more applied and seems to be the best way to ensure that your building is a healthy building and is also a durable one. So how and where do we measure, and where did we measure? So we do use the resistance moisture measurement tools. We do have to do this regularly, and the structural engineer has to double check them. As you can see, that's a very, very long and tedious process, especially if you have a very large building, which New Zealand in floor areas has. So New Zealand is not building tall like for example, Hoho in Vienna. New Zealand is building more stretched out with the large floor areas and 3 to 4 stories. That's just because we are a seismic country and you don't want to go too high because then it gets difficult with timber to build, especially with mass timber. And you have to design, you have to put other things in consideration. So what to do and where to measure? Well, the thing is, the 4787 suggests for drying timber, you should measure 300 mil from the ends. The question we asked is that enough for mass timber? And we found some guidance in the guidelines of your neighbors in Sweden from Swedish Wood. They seem to be thinking that 300 millimeters from the end is acceptable, or anything greater, obviously, to get reliable results. Obviously, as you can see, under this Swedish Wood figure here, there's a piece of floor that has seen better days and has quite a high moisture content, and has been left in the open for a while. So what else could we do? How often per panel do we measure? Well, we suggest for up to 4 points per CLT panel when we're monitoring the drying of the panel, and probably at one point where we can identify the local risk area and can predict it. So where do we place the Wiiste sensors? On this particular floor plan here, we placed 4 of those sensors in the building, and on another building, we're talking now a bit more large scale. So this is the Avida Country Club. It's a healthcare building in Queenstown, New Zealand, on the South Island. And we basically placed them around the floor and around these connections that you can see that I measured here. We need to have make sure that the moisture content is staying within the range of the acceptable threshold, because these ones here are designed for seismic forces, and therefore they have to be quite accurate. So on the building that I showed you at the beginning, you see here at the bottom left, it's close to the coast here in Christchurch on the South Island, and we placed a few of these Wiiste sensors on the balustrade to think about this. This is a large balustrade. Large is outside of the specification of the New Zealand standard. However, if you clad it from the outside, then it is possible to have it as a balustrade, or in the outside area as a balcony. Now, what we wanted to do is actually make sure that the moisture is not getting higher below this cladding, and therefore we installed one of the Wiiste sensors there, which is continuously logging. We placed some of them under the house and did some control measures just to confirm the data of the sensor is correct, and a couple of them on the inside of the building. So for what and why are we doing it? Well, it's mainly just to monitor the moisture in service conditions. Basically, when everything is finished, the contractor has left the site, and the site is basically in operation and people living in it. Then we use it in construction here in New Zealand, so to make sure if there's any issues on site and the contractor is not following the specifications, we would get an alert that can be set up, and then we could tell them, look, you need to do a better job with the moisture management on site. And last but not least, for the more for the sad part of the job, for the fact to find out how quick and how steady the existing floor is drying out, and whether it's salvageable or not. So the lessons learned by installing these Wiiste moisture meters are pretty much just a few of them now from a practical side, because that was quite interesting. So we've got to pre-drill them, obviously. Some people didn't pre-drill them, and what happened was you created an increased pressure at the tip, and that increased pressure at the tip, see the blue arrows at the top, that leads to wrong moisture readings, because the moisture meter believes you have more conductivity, and therefore it does give you a slightly off result, which was very dramatic and concerning for the client, which suddenly got a spike in his moisture and couldn't understand why. And after we found out and could ensure him that everything is okay, obviously he was relieved, and we replaced the screws and pre-drilled it, moved the sensor, and it was all fine. Another thing is to install them where the values are required. So in this case, we had a 180 mil thick glulam floor, and because we didn't want to have the moisture meter inside the shower, but wanted to make sure that we can be sure that there's no leakage in the shower, we decided, well, we're just going to install it from underneath. What we didn't think of in that moment was that the temperature gauge on the sensor, or on the sensor itself, sits obviously on the outside of the building, which is now calibrating the moisture logger to the outside temperature and relative humidity, instead of the inside where we actually want to measure it. So the results, again, were slightly off. So what did we do? Apologies for the creative cover here. I don't actually have a photo because it's not accessible at the moment. We covered it and packed it in to insulation, and we did wrapped it into membranes, which allow transpiration of the the moisture to get out, and the results turn to normal as well, or to what we kind of were expecting with the control measurements. Then for the drying out, if you have ever the issue to monitor a building and you want to find out how the drying process is working, just be aware that the timber will shrink away from the probes, because obviously when you apply the probes and you insert them into the COT at a moisture content of around 24%, which is nearly fiber saturation, you can only imagine that if the moisture drops again to 12, the shrinkage that Leif was mentioning before as well, obviously causes a gap between timber and probe, and therefore your moisture meter won't read anymore. So what do? You just move the sensor slightly in close vicinity, and then the data reads okay again. All these things you obviously have to stay on top a little bit, but since you can do that from your desk at work, or the client can notify you, this is not, it's not a huge effort compared to if you had to do it and measure on site. And last but not least, these are the guidance we're using currently here in New Zealand. So you can see the Swedish COT guide for construction. We have an Australian guide, which also has some really good descriptions about how to remediate damage on site. So I can only advise you to have a read of this. And then the US has brought out this moisture risk management strategies for mass timber buildings last year, which is also quite handy. For New Zealand, we're writing a moisture management guide at the moment. It'll be published around March next year. And the aim is to also create a specification that consultants can then provide to their contractors on site, depending on the location where they are. So they will get some good guidance from the engineers, and the engineers have some consistent information to provide, rather than having to try to make it up or rely on external guidelines that you can see here. Right, thanks for listening, and I came to the end of this presentation, and I'm open for questions. I'm just going to close this here. Hope I'm not disappearing.
Thank you, Bjorn. Really good presentation with, I think, really interesting and also useful information. And I think some approaches are a bit different, and you have some country-specific aspects had in your presentation, but quite many of those are exactly the same topics that we are discussing here. And really good also to see that you have this guidance well, it's under process but coming, because that is something that we discussed in the introduction, unfortunately in Finnish, that is something that we miss on the Finnish and on the Nordic countries in general as well. So there is a lot of guidances regarding concrete humidity measurement and many other topics around humidity management, but when it comes to mass timber, we have really limited, let's say, guidances or best practices available. So that is something that we also on Wiiste side are pushing forward and hoping that relevant players in the network and also on the office on the public side will take this ball and make things happen. But I think it's something that is speeding up, and hopefully we will have some guidances in the near future. But thank you, Bjorn. Really good. And maybe a couple of words in Finnish. Nyt on mahdollista jättää kysymyksiä sinne chatin luetaan kautta vielä. Meillä siellä 2-3 kysymystä oli valmiina. Käydään ne tuosta lävitse. Ja sitten tosiaan kysymyksiä voi laittaa myöhemminkin meille ja vastataan perästä käsin sitten niihin. Maybe one question, Bjorn, from my side. to start with just what Leif had already in his presentation, what actually the weather protection or tents, what we use, for example, on the Finnish market quite a lot, so that everything is built not under the sky, but under a protection in a tent. Is that something that you have at all on the New Zealand market? Sorry, now the connection froze for some reason. Sorry, Bjorn, we cannot hear you at the moment. How about now? Do you hear me, Bjorn? But if Bjorn has some connection issues, then we can take the Finnish questions first, and otetaan Suomen kysymykset siis tähän väliin, ja tuolta Leifille osoitettuna oli 3 kappaletta tuossa alkuun, että yksi oli, että vaikuttaako puun kasvun nopeus kuivumiskutistumaan, ja siihen liitännäisenä myös, että loppuuko puun kuivumiskutistuma vanhetessaan. Oliko näihin Leifillä vastausta?
Kyllä ja ei. Eli en ole itse asiassa ihan niin puun syvätuntija, että osaisin sanoa, että vaikuttaa kasvun nopeus kosteusliikkeeseen. Voisin kuvitella, että periaatteessa vaikuttaa, koska puuhan on yleensä huokoisempaa, mitä tehokkaammin se on kasvanut tai kasvatettu, jolloin siitä voisi vetää sellaisen johtopäätöksen, että kyllä vaikuttaa kasvunopeus myös kosteuselämiseen. Ja tosiaan siis se kosteuseläminen hän ei lopu, vaan kun kosteus siirtyy sinne puun soluseinämiin ja sieltä pois, niin se on se, mikä aiheuttaa puun liikkeen. Eli jossain tuolla 30% kohdalla, niin puun soluissa tai siellä tavallaan niin kuin huokosissa ei ole enää vettä, mutta soluseinämissä on edelleen vettä. Ja kun vesi on kokoon puristumaton neste, niin se tarkoittaa, että kun sinne pääsee tai sieltä haihtuu vettä, niin se elämistä tapahtuu ja jatkuu niin kuin hamaan tappiin asti.
Kyllä. Ja sitten siihen oli vielä kysymys, että vähentääkö hitaampi kuivattaminen puun halkeilua verrattuna nopeampaan kuivattamiseen?
Joo, eli tosiaan jos hitaammin kuivattaa, niin silloin riski halkeamien muodostumisella on tietysti myös pienempää. Ja tosiaan niin kuin yritin siinä esityksessä tuoda esille, se tarkoittaa myös sitten sitä niin kuin työmaallakin tapahtuvaa olosuhdehallintaa, että on parempi pyrkiä tämmöiseen maltilliseen olosuhteiden kuivumiseen kuin että liian nopeasti niin kuin luotaisiin hyvinkin kuivat olosuhteet. Että sillä vältetään halkeamien muodostumista kyllä. Eli malttia siinä.
Ja sitten vielä otetaan tuossa on yksi kysymys liittyen CLT:ssä käytettäviin liimoihin, että onko ne myrkyllisiä tai haitallisia ja miten se vaikuttaa kierrätettävyyteen ja miten sitten niin kuin CLT:n osalta, että voidaanko sitä polttaa turvallisesti esim. Takassa kukkapaloja ja kiellettyneitä elementtejä?
Ainakin aikaisemmin on käytetty näitä formaldehyydipohjaisia liimoja. Niissä tietysti on silloin formaldehydin päästömahdollisuus olemassa. Tietysti puun itsessäänkin on aikamoinen emissiolähde. Mutta nämä, mitä tänä päivänä käytetään, ainakin CLT-liimaksi on polyuretaanipohjaisia liimoja. Niiden emissiot on kyllä todella pienet. Sanotaan näin, että jos poltetaan, niin se on mitä nyt tiedän polyuretaanien kemiallisesta koostumuksesta, niin ei ole mitenkään hirveän isoja myrkkyjä siellä, mutta tietysti huolehtii siitä, että polttolämpötila on riittävän korkea ja tietysti välttää ylipäänsä niin kuin kaikessa poltossa, että savukaasua pääsisi sisäilmaan, että se liimapitoisuus on kuitenkin aika pieni CLT:ssä. En ole lääkäri, mutta itse näkisin, että jos huolehditaan siitä, että polttolämpötila on riittävän korkea, niin näkisin, että ei siitä mitään sen suurempaa kuin terveyshaittaa kuin ylipäänsä puun polttamisesta on. Kyllä kaikki polttohan tuottaa paljon pienhiukkasia ja erilaisia orgaanisia yhdisteitä, joista jotkut on enemmän haitallisia kuin toiset, mutta tämä on tämmöinen maallikon vastaus, miten tunnen noita tuotteiden raaka-aineita. Et jos varman vastauksen haluaa, niin kannattaa kuitenkin kirjallisuudesta tai lähinnä kirjallisuudesta sitten hakea sitä ihan ehdottominta varmaa vastausta.
Kyllä. Kiitos. Ja heräskö Leifille mieleen kysymyksiä Björnin suuntaan? Oliko Leif mielessä asioita?
Yeah. Thank you, Bjorn. You had a great presentation and good to see that in some aspects you're actually ahead of us here in Finland. You have a bit more guidance than we do here, and like I'm myself working as a moisture management coordinator, which is like compulsory from the regulations, and you had good points there to bear in mind when we do measurements in CLT structures. So it was a really good presentation and nice to see pictures from New Zealand. I visited New Zealand like some 20 years ago. It's a great country. So is it so that
yeah.
you share your presentations, so we will have access to that? Yeah,
great. Yes. And I'm really sorry I couldn't understand your presentation. It seemed like there were very valuable things from your end as well. So I'm wondering whether it's possible to maybe get this presentation, or if there's a way to translate it. So
yes,
we could probably share that with the wider New Zealand audience as well.
Yeah, I didn't have so much text on the slides. I talked more, so maybe I should add some information there before we share it to you, so you will get more out of it. Yeah.
Yes, let's do so. That would be really nice. And maybe one question I had in mind for you, Bjorn, was actually just before the connection went down, was actually regarding the weather coverage, what Leif already had in his presentation, that in the Nordic countries, or at least in Finland, we are doing a lot of mass timber projects and building those under a tent, so we won't be exposed to the rainwater and weather in general. But I think there is a lot of discussion here as well, that whether that is always needed or not, and so on. But how about in New Zealand? What is the approach regarding these things?
So I'm glad you're asking that question, because that's obviously the most efficient way to protect the timber from the moisture and from the rain and weather. And some of the prefabrication companies that do light timber framing, and they do regular houses which are not too large in the footprint in the plan view. They started using them. However, in New Zealand, to do that is very expensive. We priced it on, or we suggested that on a structure that we had in a very wet zone in this country, and the cost for a cover was around $100,000 extra, which the client didn't see the need for, and what the supplier then managed was to offer a product that would temporarily protect it during the construction, because it was glue laminated timber, it wasn't CLT. And he applied a sealer that would then obviously, something like you might have Remes or Sika over there, that probably is similar. That's what I remember from my old days back in Germany. There might be other products available now on the market. However, I think that the most efficient way is a tent, and that should be the first approach when you know that you're building in a wet time of the year, and you're building in a wet area of the country. And I suppose that's something that should be considered by the contractor and everyone in the consultant team from the beginning, and always reviewed once you start constructing, whether you're still in that window of a dry period with good weather, or whether the risk of bad weather is quite high. So it's a valid point, and it's expensive, and but obviously if you want to keep the timber, especially overseas, the untreated timber, down at an acceptable range, then tents are definitely a good way. Here in New Zealand, we're lucky, but unlucky in a sense. We still have the chemical treatment, so we don't have as much the problem with decay. We do have the problem with mold, because mold grows regardless of whether there's the conditions for decay. So at 19% moisture content and certain temperature, it starts growing mold, and black mold is hazardous for your health, so it's not a desirable thing to have. However, the building will not collapse because we've got the chemicals in that stops it from rotting.
Yeah, thank you. And then we on Wiiste side don't want to take any kind of recommendations, or we do not have the expertise to say yes or no, but that's definitely a difference what we see, not only between New Zealand and Finland, but already here in the Northern Europe. I think countries like Norway, which is more exposed to coastal climate and rain, they don't use as much covers as we do, and this is an interesting topic, and maybe a good topic for a webinar at some point as well. Pros and cons, and how you can act if you use or if you don't. So maybe something for the future.
I agree.
Good. But now I think we are pretty much have used our time, which was until 11:30 Finnish time, and it's about the time Bjorn needs to get into the bed at your end, and then our Finnish audience is about to have the lunch time. So I think now it's a good time to thank you both, Bjorn and Leif, for the presentations and